Good morning, everyone. Welcome to this second SWIM webinar organized by the Cesar Deployment Manager, EUROCONTROL NN, and the A6 Alliance. My name is Cristian Pradera. I am the Planning Manager in the SDM, and I would like to welcome you all to this second SWIM webinar focused on supporting the implementation of SWIM services to all the operational stakeholders, and today focused on meteorological SWIM services. This is a second webinar that we organized following the first one that took place before summer, focused on the SWIM registry hosted by EUROCONTROL and also on some existing SWIM services, in particular CoFlight cloud services implemented by INAF and DSNA. Today we have a 2 hours webinar where some colleagues from the meteorological community and also ANSPs will address and introduce some SWIM Met services, and we do hope that you will find this webinar useful. Before starting, I would like to give you some practical details or logistic details on how to participate into this webinar today. First of all, considering the amount of people connected, which is a very good signal, please mute your microphones and turn off your cameras. This webinar is going to be recorded so that we can share it afterwards with all of you and also those registrants who were not able to connect today. The idea of today's webinar is to address some SWIM Met services, but also to give the opportunity to all of you to raise questions and hopefully have an interactive session. If you have questions throughout the presentations, please use the chat to address them. We will try to answer as many as we can, considering the time constraints. But in any case, all the questions, even those that cannot be picked up today, live, will be answered after today's event, and we will share answers with any of you bilaterally in the following days. If any of you face any technical issues, problems with the connection, with the visualization of the slides, whatever, please drop us an email into the email address that you can see here below in this slide. Our colleagues will try to assist you as soon as possible. With this, let's have a quick look at today's agenda. After my opening and welcoming, I will give the floor to my colleagues from SDM and EUROCONTROL, Magnus and Rosalind, who would become the Masters of Ceremony and will guide you through all the presentations and will moderate the webinar and also the questions and answer session. We'll have an overview of MedSwim from UMedNet. Then we'll have a short journey through UK Met Office. Afterwards, we'll have the SWIM service description from the Met perspective. This will be provided by the German DWD Met service provider. And finally, our colleagues from ENAIRE will present some SWIM meteorological implementation services, ICAROMAP, that they have been working on lately. We will close the webinar with this questions and answer session, which will try to make it as interactive as possible. Again, raise your questions in the chat and we will address them at the end of today's webinar. With this, we start with the content of today's webinar. I will introduce just a couple of slides to provide some background on the SWIM services that are included in the regulation and therefore are mandatory to be deployed in Europe by a number of stakeholders. And after that, I will give the floor to my colleagues. As many of you may know, the pilot common project implementing rule was launched or published by the European Commission in June 2014. There we had 6 ATM functionalities mandatory to be deployed in Europe by different stakeholders, and one of them was about SWIM implementation, where a number of services to be SWIM compliant were addressed. After 7 years, the Commission decided to update the regulation, the pilot common project, and this year, in February, the SESAR Deployment Manager sent to the European Commission an update of the regulation called CP1, Common Project 1, and the European Commission endorsed it and published it in February 2021. So the Common Project 1 is now repealing the former Pilot Common Project regulation. Please note that content-wise, SWIM, AF5 in this case, ATM functionality number 5, remains there with very little changes. But in particular, all the SWIM MET services that were included in the PCP are still there with new target dates, but still mandatory by the targeted stakeholders. The implementation target date set forth in the new CP1 for SWIM services is 31st December 2025. How do we address the implementation in the SESAR Deployment Manager of all these 6 ATM functionalities? We elaborate the so-called SESAR Deployment Program, which is the guidance document for the stakeholders to implement the 6 ATM functionalities, and in the case of SWIM, all the SWIM-related services. We have recently updated the SESAR deployment program, which contains all the details in terms of milestones, synchronization needs, etc. This year also, after a period of 6 months of consultation, the first half of the year with all the operational stakeholders. This updated SESAR deployment program was delivered to DG Move, European Commission, in July this year, and is pending formal approval from the College of Commissioners. So please note that the document itself has not been formally endorsed yet by the European Commission. We expect it will be endorsed first quarter next year, but we are also pending receiving some comments from the European Commission regarding the content of the SDP, and therefore there may be some changes compared to the existing version of the SDP, which again has not been formally approved by the European Commission. This document contained deployment milestones, Gantt diagrams, a description of all the technical and operational elements that need to be implemented in order to achieve in time the 6 ATM functionalities, and in the case of SWIM, all the SWIM-related services. With this, I will not waste much more time on the details of the SESAR deployment program. I invite you to visit the SDM's website and to have a look into it if you are interested, always with the caveat that the final version of the SDP endorsed by the European Commission is expected by beginning of next year. So with this, I will hand over to Magnus and Rosalind. As I said, I hope that you will find interest in this webinar. And again, I encourage you to raise any potential questions through the chat. Thank you very much. Magnus, floor is yours now.
Thank you, Christian, and thank you all for joining. I'm going to build a little on what Christian already mentioned about the SESAR deployment program, but specifically one family is in focus today, is family 541 of the SESAR deployment program, which is about MET SWIM services to be implemented. So on the left-hand side, you see the 6 ATM functionality, and the one ringed in, I would say, with the orange color is the MET family. What is important is that there are milestones, as indicated by Christian, per stakeholder, and MET, you have actually 18 milestones to implement and report on here in the SESAR deployment program to become compliant with the CP1. Next slide. Yeah. So what is actually the status? So we are trying to capture it a little here. We as you know, we have launched a new process this year together with EUROCONTROL. So it's end of double reporting. So it's LSIP. So we don't have new data to actually show a current status. We have 2020 data, which is old now. But looking at the MET services, then we have 27 MET providers approximately mandated in Europe, and that leads to approximately 83 MET SWIM services to be implemented. The status today is that we have, I think, 17 or 18 operational swim services in the swim registry, which is a piece of the cake already done, but I think we still have a big step to take. So the med providers specifically has a lot of actions to take. Bear in mind the deadline is 2025. What is very, very important also on this matter is that the service consumption. So we don't so far have any reports of actually any stakeholders consuming the med services that are available now in the swim registry. Now it is pretty new that we have med services there, but still it's a very important step that we start consuming the med services. Having an overlook and putting it into context a little bit, then there is 21 mandated CP1 swim services in total. That has to be implemented by all the mandated stakeholders, which leads to minimum 260 operational swim services that we need to see in the swim registry by 2025. Today, we have 45 services in the swim registry, and that is including the newly swim compliant NM B2B services who are also in the swim registry now. Of these 45, we have 28 that are swim. No, not swim, sorry, but that are CP1 swim services. They are indeed all swim services. There are also services being finalized, 8 services, whereof 4 are med swim services. So I think we can say that there is a lot of progress ongoing, but we still have a big piece to still work on in Europe, and we need to also start putting the focus on the swim service consumption. And by this, I will pass the floor to Rosalind, sitting next to me.
Hello, and thank you very much, Magnus. We're going to hear very shortly from quite a number of our European Met service providers, but really just to kind of set the scene a little bit further from Magnus's introduction. If we look already at what the Met service providers have done, they're already publishing a lot of the relevant Met products in the new iWixom format. That is already reasonably well established here in Europe. Some have also deployed new swim services, which were first developed in Cesar 1, have been through the deployment process and are now live, and as Magnus has just explained, are available already in the swim registry. These new swim services are focusing particularly on harmonized inputs between numerous different states and are pan-European services, both observations and forecast services. And we also have well-developed plans for some of the other services which are produced by the WAFs, which is the Global Upper Air Forecasting, the Volcanic Ash Advisory and Tropical Cyclone Advisories that we are responsible for here in Europe. Those centres also have plans for developing swim services for those functions. So what are some of the concerns and risks? These will undoubtedly become more apparent as some of the other speakers explain what they have been doing and how they are progressing. But some of the main concerns that we have noticed, I think Magnus already mentioned, we don't yet have anybody that is actively and operationally using iWixom yet, and we perhaps need to look into some of the reasons for that and how we can accelerate that process in terms of the uptake of this new data format. We have some very limited anecdotal feedback at the moment that there are perhaps some inconsistencies with the way that iWixom is being produced at the moment that is causing errors in some systems. And there's perhaps some further investigation that we can do in this regard to make sure that we mitigate any risks associated with not having a harmonized implementation of this. So that's something that we will be looking at in a little bit more detail. We are also in the case where almost all EU implementations of the IWIXM are simply translating the old format, which we refer to as the TAC, the traditional alphanumeric code, which is what we would all regard as things like the SIGMET or the TAF or the METAR. The easy solution for creating IWIXM is simply to translate that old format into the new format. And that's what's happening in most cases within Europe. But it's important to recognize that this is not the long-term solution. This is simply an intermediate stage. And the long-term vision, not just for us here in Europe, but as a global standard, will be that the IWIXM will no longer be a translation, but will actually be the ultimate, the original source of the data, whether that's an observation or a forecast. And of course, once that happens and the full functionality of the IWIXM can be realized, there will be, of course, more incentive for users to switch over and use these new formats. In terms of usage, we've already mentioned that there's no specific users using IWIXM yet. And that's something that we do definitely have to address. It's nothing new, and we should remember back several years now that even when we were working on the developments within Cesar, there was also a lack of engagement with users in the Met aspects of Cesar at that time. The project that was developing these new Met services really struggled back then to find projects that would validate and include that Met information. So it's not necessarily surprising that at the moment where it comes to the actual deployment of these services that we're in the same situation where users are not ready yet to accept and ingest this new information into their decision-making processes. But it's something that we need to engage with. So some of the other concerns that we have is how do we ensure the smooth transition from the TAC into the IWIXM? And at the bottom box here, I'm highlighting that it's also important to note that delivering Met information via SWIM services and in these new formats is the way of the future. This is how things are going to evolve, and therefore, although we are in a transition phase at the moment, it is going to be temporary, and we have a limited period of time to make these changes. To put this into context, if we look at the global plans for the implementation of Met and SWIM in the future, what's on the screen here is a reference to some of the ICAO documents which set out the plans and the roadmap for the implementation of Met SWIM in the future, which is a useful reference point to see how the global rollout of this is envisaged. And finally, from me, some of the actions for both the providers and the users, which we would like to focus on, is not just on the legal obligations to comply with CP1 and the state obligations associated with that, but also about the practical implementations as well. How do we get to that end point? And that will involve active engagement between the Met service providers and the users of these services, so that you can envisage how this new information could be used in the future. And the implementation of SWIM, bearing in mind that the end point is not just the format change, but to realise the full potential of this new technology. And that's it from me. Thank you very much.
Cool, thank you, Rosalind. So I'm next. I'm Lauren Donoghue from EUMETNet. And for those of you who perhaps aren't that familiar with EUMETNet, it's not a Met service. We're an economic grouping of many of the Met services in Europe who work together on quite a wide range of topics, Met-specific ones, looking at observations and research into forecasting practices, but we also have an aviation program, which is what I manage. So I'm a bit of a focal point between the Met air navigation service providers across Europe, helping them to understand what's coming in terms of regulation in the future, but also to talk to the aviation community and remind you all that Met is here and how I can help support you and how the Met community can help support you. So the outline of our presentation today, I'm just going to cover a few points around why the regulation exists, what Met why we're here to help the aviation community. And then I'll hand over to David Sutton from the Met Office, who'll talk about the Met Office's swim journey and things that they've learned over the last few years. And then hand over to Jens from Deutsche Wetterdienst, who will look more specifically at their swim service descriptions and some of the learnings that they had as they developed their swim services. And then we'll come back to me and I'll talk about some of the services that were developed in this SDM projects that we've been working on and are coming to an end as we speak. So hopefully it's not surprising to anyone to learn that weather is everywhere. It's not just at the surface, but it's also up high, throughout the column of atmosphere as you fly. And obviously, as you fly, you experience weather through the whole length of your flight, from when you're at the airport, as you ascend en route, and then again as you land. At every stage, there's a weather forecast that's been provided by your local Met ANSP for that purpose. And within globally and also Europe, but also at state levels, there's different regulated products that are provided. So I'm sure you're all very familiar with METARs, TAFs, SIGMETs, and also WAFC products, which are very much at a global level and provided by every Met service or every Met ANSP for every major airport. But also at a European level, there's some specific regulated products, and then again at state level there might be something very specific for certain airports, or maybe for helicopter operations that are specific to those users. And while in many cases that weather information, a METAR for example, always has the same format, we're looking to try and improve the way that the weather information that we have is available to the wider aeronautical community. It needs to be available in a consistent way, and while there's many different Met providers, we want to ensure that you all are seeing the same information as best we can, particularly in Europe, where we have so many different states and different methods for accessing the information. So as Rosalind rightly highlighted, we have ICAO regulations, particularly ICAO Annex 3, which defines many of the Met services that we provide. And then that also is being worked on by the Met panel, for example, and the MIE working group at defining how swim services will develop at a global level. And also we have the WMO, the World Meteorological Organization, who helps define and structure the schemas and formats that we use for Met data. So when you see GRIB2 and WIXM, a lot of that comes from that type of management at a global level. At the European level, again, I'm sure many of you have heard of the regulation 373 Part Met, and that has mostly transposed what's at ICAO Annex 3 into European law. And then there's some small variations within that, but that's what drives a lot of the work that we do. And then, as has also been mentioned, we have Common Project 1, which very much highlights how the Met services that we are already providing will be moved in towards SWIM. And that includes existing Met services, so again, METARs, TAFs, GRIB2 data or WAFC data, but also new things that are available as part of the Cesar 1 work and the Cesar deployment. So just to list them there, we have volcanic ash mass concentration services, so the VACs, VAC London and VAC Toulouse, very much focusing on those in Europe. But we also have aerodrome meteorological information, so what's happening at the airport and in the local vicinity, en route, and network, which are very, very similar, but have perhaps different focuses depending on the users who will be accessing that information. As has been highlighted, we're doing that development now through the Met services, but quite often we lack some of the fundamental, we know the requirements for some of these services, but getting further engagement will really help ensure that the services we develop are valuable and useful to you. Again, as Rosalind mentioned, iWixom is now quite common and used and has been available, needed to be available since last year as part of our regulations. And then further things are coming online November this year, so I suspect it's next week where the volcanic ash comes online, and then WAFC updates will be coming online next in 2023 rather. And as all things in aviation, these things take time to implement and to put into place. So in many cases, the TAC, the traditional alphanumeric code of Wixom, of METAS and TAFs, are being translated into iWixom for use because that's the tools that we have available at the moment. But the intent is that long term, it will happen natively. The observations at the aerodrome will be converted into Wixom and then available to the consumers both at the airport, but also any others who maybe find that relevant. And that's a long process. It's a change of technology. And as we know in the aviation world, sometimes changing technology takes a while, but it's really important that we start considering how we're going to do that and when we're going to do that to both comply with regulation, but also let's bring this, into the 21st century and be really, really thoughtful as to how we're going to provide our information. Just also to highlight at the moment, many of the schemas that are used for Wixom have focused on the existing Met products that are around, but there will be more coming online in the future. So at the moment we have polygons for WAFC data, but actually in the future we may have polygons for other types of data. And so those different schemas will come online slowly but surely eventually. And what we need to stress is that anyone can develop a schema, and if it becomes one that's commonly used, it will go through to WMO to sort of publish more widely. So on that note, I'm going to hand over to Dave Sutton.
Good morning, everybody. My name is David Sutton. I'm a Senior Product Manager at the Met Office, and for the next couple of minutes, I'm going to be talking about our Met Office journey into SWIM. First of all, a little bit about us and our credentials. Working with SWIM, we've been pretty much working with Cesar, IP69 and IP68 and IP67 over the last 24 months. So we've got kind of 24 months experience working with and delivering SWIM services. We've had a lot of interaction, obviously, with IP69 and IP68 in the delivery of SWIM for working with DWD, Meteo France, and ourselves at the Met Office. In the future, the Met Office's plan or intention is to take a SWIM first approach for all new Met Office aviation products. So those could be global products or European products, etc. We're also, at the Met Office, we're also taking a cloud-first approach. So we've had to do a little bit to go along the journey of working with how Amazon Web Services, which is our preferred cloud provider, complies with SWIM, and how the services we build on Amazon Web Services can become SWIM compliant. How the Met Office works, it tends to go through a think, shape, create, and operate phase. So when we are implementing SWIM, we've got to build that into how we develop our products effectively. So we look into SWIM and see how we can front load what we need to do with SWIM in terms of how we develop our projects. In terms of the actual technical delivery of delivery of the SWIM services, we've worked with our development teams, and what we tend to follow a similar profile as this. We take the SWIM yellow profile, which is pretty well understood and very well documented, and then what we do is we actually do an investigation spike over 5 or 10 days to see what we need to actually do to implement SWIM properly. We'll then document the findings. We'll generate a SWIM compliance checklist to make sure that what we develop and release at the end is actually SWIM yellow profile compliant. And we'll also implement our decisions in the business decision log as well. As Magnus talked about earlier, there's a sort of open question about usage of swim data, and I think at the moment there's an open question about how the Met Office itself can leverage the benefits of swim as an actual consumer, not just as a provider. Here's a little diagram explaining how the Met Office's think, shape, create and operate process runs, and also where the big swim touch points are. In think, we come up with a very, very high level plan about what we want to do. But in shape, which is when we begin to look at the technical architecture and the design for the technical architecture, that's when we really start to engage with swim. So as you can see, there's a swim touch point there. We'll engage the technical architects in order to make sure the service we deliver is swim compliant. Of course, when we go into create, which is when the technical developers begin to do some coding, that's when the swim really hits home, because we've got to code the system and design the system so that it maintains its swim compatibility. Another big touch point, of course, is when we actually do operational acceptance or quality assurance, if you like. The Met Office makes sure that when we go live, we've got an operating acceptance license, but we've also got an additional body of work to do to ensure that we are swim yellow profile compliant as well. Once we go to operation, it's fine. Then we do iterative releases, version 1, version 2, version 3. But we shouldn't forget that every time we release a new version of a swim compliant service, we've got to make sure that the swim service description in the swim registry, is actually up to date as well. I'm going to talk about the Met Office's swim journey from 4 separate perspectives. As the product owner designing and delivering a swim compliant service, as the swim service description author, writing the swim service description and publishing it to the swim registry, as the operation acceptance compliance auditor, if you like, to make sure that not only do we meet Met Office assurance to go live, but we also meet swim yellow profile assurance to go live as well. And finally, as the solutions architect. Okay, first of all, I'm going to be the product owner designing a swim compliant service. From my experience as a product owner doing this work, it's essential that you obtain a solutions architect or well-qualified technical lead to actually understand and design around the swim yellow profile, okay? This was very much facilitated for us through the excellent support, or the great support we've actually had from EUROCONTROL Swim. That includes access to people and the documents that are available for us to download and to view. Our development team and the solutions architect really got swim in the end, especially the swim yellow profile, of course. But there's always a risk that my technical development team will move on to other projects in the future. So there's a risk that I might be onboarding a new team that I've then got to take on the swim journey again. Inside the Met Office as well, we've got lots of internal dependencies, things like authorization and authentication, security, archiving, and business onboarding of customers as well. So what I'm trying to allude with this point is that it's not just about designing a swim service, but sometimes it's also about aligning that with the existing dependencies you've got in your organization. So there was a little bit of work we had to do there to make sure that our common approach at the Met Office for authorization and authentication was also swim compliant as well. We have work to do, of course, to make sure that any communications we give out from the Met Office also match with the communications we put in the swim registry as well. So we've got quite a lot of alignment pieces to do. Another example is in the product or service version that we launch, we've got to make sure that is actually aligned with what we've written in the swim registry. So if we make a version 2 or version 3 of a swim service, we've also got to go through a release process to make sure that the swim service description is still in alignment with what we've released in the new software. Further to that, of course, is in case of audit, we've actually got to archive our original swim service descriptions as well, so that we can match a release with a swim description, a different release with a different swim description, for example. Then, of course, we've got to do compatibility checklists at the project end. The final thing I would say is there is a significant amount of resource for developing, testing, assuring, making sure that we are swim compatible. Now, I'm going to take you through the journey as a swim description author. When myself and my colleague Alice were writing these swim service descriptions, we found that having a good and fast access to our technical team and development team to advise us on the applicability of what we'd written was very useful. So I'm just saying there, you really need to have a hands-on approach to your technical team to make sure that what you're writing as a service description author matches to what's actually been delivered. As a swim service description, it's also imperative that you set up your own swim registry account. We also found that there are great support assets from the EUROCONTROL swim registry, again in terms of people, documents, frequently asked questions, etc. We tended to use a JSON validator in order to check that our swim service description syntax was correct. For example, making sure that we had open and closed brackets as pairs. Working with other teams, of course, we found that it was useful to use capabilities such as GitHub in order to share thinking, working, and examples of swim service descriptions and code, for example, with external partners. For example, DWG and Meteo France. Internally, we use SharePoint. The swim service description or glossary actually really helped us as well. So that made sure that even though that we were exposing slightly different services, the terminology we used to describe the service to the end customer was all consistent. So the glossary helped a great deal. Okay. We also found it was great to actually do a peer check on the service description work that we've done. So what I'm saying is that we needed effectively two people, one person to write the service description, the other person to check it, and vice versa. As a negative, we have found some issues about specifying the geospatial coverage in the present schema a little bit tough. An example there would be making sure that we're mapping ICAO nationality letters and FERS to the spatial areas that we're covering. So we're looking forward to a capability where we can describe the spatial coverage of the swim service using sort of latitude and longitude coordinates. Okay, now I'm going to talk a little bit about being an auditor, validating that the service that we've generated is actually still swim compliant. First of all, the Met Office mandates that any service that we release must meet internal operation acceptance criteria, or OA criteria, before we're allowed to go live. So operational acceptance overlaps many of the swim requirements, so there's actually quite a lot of duplication for us to do when we're doing quality assurance. There's over 100 separate components or things that we need to tick off in order to make sure that we meet operational acceptance, so it's not a small thing. We tend to do the operational acceptance alongside the actual development towards the last quarter of the project. So I guess what I'm saying here is that just to finish the Met Office operational acceptance, we've got to take into things like security, scaling, auditing, authentication and authorization, logging, monitoring, alerting, etc., capabilities. And what we found is there's actually quite a lot of duplication between what the Met Office is asking for us to do, along with the swim yellow profile as well. So there's a bit of duplication of work that we do in assurance. As a result, after we've got the operational acceptance, we then go through another body of work, which is checking that we are swim compliant as well. So we've got a separate checklist for that we also make sure we've ticked off before we're allowed to go live. When we did it last time, it took over 2 days, and it involved the product owner, the technical lead, and the solutions architect working together to make sure we'd gone through those lists and ticked off all of those boxes. We are finding that as we develop more and more swim experience, this process is getting faster and faster. And I guess we're really looking to try to align the Met Office operational acceptance with the actual swim acceptance as well, in order to reduce duplication and make things faster. Again, as I said, because the Met Office's approach is Amazon Web Services cloud first, it's really paid to try to align a subject matter expertise with Amazon Web Services cloud and also the swim yellow the swim yellow profile. So there's some alignment there to do, just to make sure that what we build on Amazon Web Services cloud matches swim. Typical examples might be how we scale in Amazon Web Services, how we manage security, and how we do alerting and archiving in that. We've also been greatly helped by an external audit and report from the EUROCONTROL swim auditor, who looked at our swim services and offered us some suggestions about how we could tighten them up. So thank you for that. Okay, the final person that I'd approach as a solutions in order to look at our swim journey is as the solutions architect. I think the only thing that we came from that angle was there was quite a turnaround time from us being able to suggest an edit to how the technical swim yellow profile is, and how that edit can be okayed, accepted, or sort of presented to the swim boards. We've currently got a query over pub sub issues regarding notification from multiple consumers. However, the solutions architect and the technical lead have always reported they've had great support from the EUROCONTROL swim team. So their technical questions have actually been responded to relatively quickly, enabling us to develop on time. And the only other thing was a suggestion from the solutions architect. They really preferred it when the yellow profile was actually provisioned to us as a website as opposed to a PDF. Drawing to a conclusion, the takeaways I'd like to present to you is that it's going to be the Met Office's policy to expose all new aviation services as swim yellow profile compliant wherever technically possible. We are finding that as we build experience into swim and Amazon Web Services Cloud, we're also beginning to build faster and more efficiently. I've got a body of work to do, as I said earlier, where I do better alignment between the Met Office internal assurance or operational acceptance and the swim yellow compliance work as well. Swim does cost to implement. I guess the biggest source of costs was actually aligning how the Met Office's existing organisation structure can actually be tuned or changed in some way to make sure we're swim yellow profile compliant. Perhaps the best example of that was over authorization and authentication, in that, as I said earlier, the Met Office has got a common policy or strategy for Auth and Auth. We had to do quite a lot of internal work to make sure that the swim yellow profile pattern that we chose was actually swim yellow profile compliant. I'm actually become more and more of a fan of standardization, and it's a great thing to explain to our end users. So we're fully behind swim. It will be a great day when we can say to them that our aviation services are swim compliant. They are by API. We follow the EDR format, and to move it along those lines in terms of standardizing our output to make it easier to explain to customers what they're actually getting. That wraps it up for me. So if it's okay with Lauren, I'll pass you back. Thank you very much.
Thank you very much. And then we'll go forward for, oh, you had 2 more slides there. Dave, did you want to present them?
Well, very quickly, that's just an example of the audit process that we go through to check that the TYP yellow profile particulars actually match what we've delivered. That's one example of perhaps another 5 or 6 pages. A very quick example of how we're doing auditing in order to check that we are available, in order to check that our end user requests are being met with end user responses. And finally, Lauren, we've just got some information about availability for our swim web services. So that's just the icing on the cake. Thank you very much.
Thank you very much. I think we're taking questions right at the very end today, so I'll hand over to Jens at DWD instead. Thank you.
Hello, everybody. My name is Jens Kuschake from DWD. In my part of the presentation, I want to present how DWD provided service description in the registry, which problems occurred, and what are the future aspects to look at when it comes to service descriptions. First, I want to start with a short introduction. What is actually a service description? A service description describes the what and the how. That means It describes what data is delivered through a service and how consumers can consume a service. Through a service, you are able to provide and consume data. The service description is written in JSON, and an extract you can see here on the right-hand side. The service description can be validated with a JSON schema, and this schema follows the specification for SWIM service descriptions. And this again follows the needs of the specification for SWIM technical infrastructure yellow profile. Both you can download from the website of EUROCONTROL. But how do others know my services? For this, there was a registry developed. The SWIM registry allows users to discover services. It's a regional, centralized system so that everybody who wants to provide data within EuroSWIM needs to provide also service descriptions in the registry. The registry is hosted by EUROCONTROL. The registry itself uses a JSON format in the background to store the metadata. On the website, you won't find any JSON. It's looking there in a nicely HTML view. I put the link to the registry at the end of the presentation. To explain the picture on the right-hand side, a provider who wants to provide data is publishing their service description in the registry. A consumer who needs some data finds this service in the registry and uses the data from the service description to consume directly the data from the service provider. In this slide, I want to show you how services looks like in the registry. On the website, you will find an overview page. On this screenshot are only 6, but if you scroll down, you will find some more. And if we zoom in, you will find more detailed information, the name of the service, the version number, provider, and then short abstract. And if you click on one service, you will find some more overview information, and you will find some more detailed information. The detailed information are ordered in different tabs, in different horizontal tabs, and in different vertical tabs. We have been providing 4 different services in the registry at the moment. There is an OPMET data in IBIXen via WFS and OPMET data in IBIXen via AMQP service. And OPMET data means it includes meter, TAF, and segment. We split these actually one service into 2 services due to the fact that there are different interfaces and different data structures of both. Also, we are providing harmonized icing intensity data and harmonized turbulence data in AMQP, in CLIP2 via AMQP. Both results from the Cesar IP68 European Harmonized Forecast of Adverse Weather project. For the future, it is planned to provide also NAPAS mix data and IRMA radar data in the registry. But how to get actually into the registry? There's one prerequisite to do. Of course, you need to have an account with the ability to create new services. So just go to the website, register for a new account, and request the right. Then, if you have done this, you've got 2 options. The first option is just write the service description in a JSON on a JSON editor on your computer, validate it, and import it to the registry. The big advantage is you have the full control of your service description. You can change everything. The disadvantages are that you might run into importing errors because of different validation engines on your computer and the registry itself. Also, for example, and you might check if everything is imported properly. Also, for example, if you have additional documents, you need to upload it separately and you need to link to these documents then directly in the registry. The second option, what you have is you can write the service description directly in the registry from scratch. The registry offers for this option forms to enter your metadata for the service. The big advantage is that you don't have to care about the right syntax. And the second advantage is that you don't have to care about the validation because it's already integrated in the registry. The disadvantages are that the editing mode is a little bit slow, so you sometimes need to wait 1, 2, or 3 seconds until the data is stored. And also the editing mode differs a little bit from the non-editing mode, so this might lead into difficulties to put the right information in the right section. For example, you need to have in one screen open the editing mode and in one screen open the viewing mode, and then you need to store firstly in the editing mode and to look how it looks like finally in the viewing mode. So this might be a little bit complicated, but it's working. And last but not least, for the disadvantages, it's not possible to copy a whole service description or to copy a section from another service description. So you need to enter everything again for new service descriptions. And the last disadvantages was a reason because we have done a mix of both. So we did once a service description from the scratch, and then we exported the service description and changed the name of the service description, imported it again, and then changed the rest of the information. Which information is actually needed in the service description? I showed you already in the beginning a detailed view of the service description. You need to fill some overview information and also different sections. For example, the general section, information definition section, technical section, an interface section, and also some references. And you will get an impression what to fill out if you just look at the registry and look what others filled there. But if you need some more help, you can look also at the specification for service description, which is the base for the service description. I put the link also at the part of the end of my presentation. And also, where you can look at the service description handbook, which is hosted by EUROCONTROL on a wiki page. And yes, there you find more detailed information and also some examples what to put in the right fields. But also the registry itself offers information what to put into the specific fields. You need to go for this to the registry website and click on documents and further click on data structures, and there you will find some information for every element. And if you have further questions, they always can be addressed in the sessions of the SWIM community of interest, also held by EUROCONTROL, or you can also contact EUROCONTROL directly. What are the future challenges when it comes to service description? We identified that there is some harmonization needed, for example, in structuring. You can structure the services with the kind of data like we have done. We combined the TAF, SIGMET, and META service to one service. And you can structure it also like a way of distribution and, for example, put everything together what is MKP and everything together what is REST, for example. And there's also harmonization needed for structuring because there are often free text elements in the service description, which leads to different explanations of the same things. And this might be difficult if you have it one day in a machine-readable way. On the next two slides, I will have two examples, one with the information definition and one with the interface name element, which explains this a little bit more. But this harmonization is already addressed for the SWIM community of interest. If you have suggestions to how to solve these problems, or if you want to talk about with us for this, you just feel free to attend these meetings. Here in this slide, I want to show you the example for the harmonization issue of the elements. The service description specification is often like that you need a name and a description for everything. Also for the interface, you need a name and a description. Here on the left, I displayed you two different services. Both services offers their data via WFS. Both have different names and description for the interface. And also for the operations. Both have different names and descriptions for the operation. In my opinion, it will be more easy for the user if data which delivered in the same way will be shown in the service description also in the same way. Another example is the information definition element. Here you can see in the red circles 4 different services and 4 different explanations of this information definition element. But despite this missing harmonization, it shouldn't keep you away from just providing your services in the registry. But how to start now? Just create an account, request the rights to publish your services, export an existing service description, change at least the name of the service, upload it into the registry again, and change the rest of the elements so that it fits here. So that it fits to your service which you want to provide. And finally, just publish the service. During my presentation, I refer to a bunch of websites. On this slide, I just want to give you the opportunity to take a screenshot if you need and want to use the links again. And now I want to hand over to Lauren again.
Thank you very much, Jens. I think you highlight very well that even within the MET community, we have challenges to produce the services, but they are there, and we very much look forward to having users give feedback on those, because we can't improve those service descriptions until we know how they're being used and perhaps what limitations are there. So just to finalize this side or this element of the MET presentation today, we're going to look a little bit more at the MET services that we've produced very recently as part of Cesar Deployment Manager projects and those CEF projects. So as a general reminder, I said it earlier, there's many different types of formats for Met information. Some are quite common, GRIB2 in particular, and NetCDF, quite common, but we also have elements like HDF5, which are much more of a Met type of format, but actually something that is much more natively useful for certain weather parameters. And we also have, so that's for gridded data and polygon data, IWIXM, XML, GeoJSON to help deliver that information. Traditionally, weather data is sent out as a chunk of information that covers either the whole globe or a particular domain for a large time step. But particularly with swim services and the digitization of the aviation aeronautical information, it's worthwhile thinking about, well, how do you use your data? What do you want to do with it? Do you need the whole globe's worth of information? Or perhaps you're just interested in what's happening over Europe or within a FAB or within your country or even just around your airport, and think about how you use the swim services. Do you want to take a cutout? I'm thinking in particular about the weather radar product that I'll show you in a moment. That's quite a lot of data every 5 minutes. And while obviously the delivery of those is set up to be able to deliver that every 5 minutes, you might consider that actually I'm only interested in what's happening in the 100 kilometers around my airport. I'll just get that information. Equally, gridded data is obviously quite high volume. Perhaps you'll find it more relevant to have the polygon data, or perhaps just a single point of that information that's relevant to you. So kind of trying to stress to think about how you use your information and what you want to do with it. And I would really strongly encourage you to talk to your local Met ANSP, your local Met providers, and talk about, well, what you want to do with it, what you could do with it, and what they have, so that we can make better use of the data that we have. And on that theme, I talk about gridded data. So on the left-hand side here, we've got the winter weather product that we've produced as part of the deployment projects. That's looking at different types of precipitation and their likelihood. And maybe your operations network manager, for example, are interested in having a very wide view of the types of weather that are, or precipitation that's going to occur, and just want to have that quick lookup. But equally, perhaps you're based at an airport, or your flight operator, and you want to know your city pairs. You can instead perhaps get data in a different way to be able to see, do something different with that information. So on the right-hand side here, instead we've got probability of different types of precipitation, whether that's drizzle or snow or freezing rain, and how you make a decision with that. Now, what I've got here are some visualizations, but the swim services that are produced are all data. It's not about the imagery, it's about the underlying data. So one thing to stress, I'd like to stress a lot, is that while I'm going to show some pictures coming up, because that's the nicest way to show Met information, everything on the swim registry at the moment is just pure data. And so it's up to you as the user to think about, well, what do you want to do with it? And again, think about what questions you want to answer, what problems you're trying to solve, what decisions you want to make with this type of information to help you do your job. Obviously, weather's all around us all the time, but it's only sometimes that it's more significant to be interpreting and understanding for your operations. So I've just got to, as I say, show some images of a few different products that we've had come up as a result of the deployment project. So one of them, IP67, for those who like numbers, is the 3D weather product, also known as IRMA, which instead of taking a single layer of precipitation observation, which is what most of us are familiar with when you think of a weather radar image, this actually looks at through the whole column of air of atmosphere to understand where precipitation is, and therefore what can be inferred from that is about convection, so perhaps how tall convection is occurring, and how it's moving. And this is a really new product and something that we we feel there's a lot of potential for, but as yet don't have users using the information in a way that we think might be, might support operations, particularly, as I say, around convection. We also have combined products of icing, which I've got on the left here, and then we also have turbulence, where we've combined multiple models into a single product of like I say, turbulence and icing, upper air icing, to understand at a higher rate or time forecast period where those phenomena may occur, which at the moment you could be used in different parts of flight planning. We also have convection products, which you probably can't see my mouse, on the left-hand side there, looking at polygons, but that will also have nowcasts of turbulence coming up, and also of winter weather. So just a few examples on the lower edge of your screen and on the right-hand side, and what you saw in the previous slide showing precipitation risk of different types of phenomena, which is obviously much more useful perhaps at an airport. Now, as I said earlier, those were just images of those weather types. But what we know is that from a service point of view, you want to do something with that information. Being presented with a pretty picture doesn't necessarily help you make a decision about your operations. And so I'm just going to show a few ideas that we've had on how weather information could be used, but also we would be really interested to know what everyone else might do. So on the map here is obviously just a picture of stolen off the EUROCONTROL's NOP, but what it's showing is different parts of information areas or air traffic control areas changing colors based on certain information. And this would be really useful to use in a dashboard using a convection service or the weather radar service, but also turbulence and icing, to show our thresholds being exceeded. Therefore, this area we want to pay more attention to from an air traffic control point of view. Equally, you might have other services combined with the weather to help create this dashboard. So perhaps there's more flights going through that area. So the weather itself isn't a problem, but as soon as you exceed a certain threshold of flights, then there may be capacity issues. And so there's lots of different ways to try and use this information instead of just the raw weather, but to combine it with other systems that help you plan, make decisions tactically, but also plan for the next 24 hours or 5 days ahead. So that's sort of more for the en route network type of view. We also have ideas around how some of these services might be used more at a local level. So these are still images that I've borrowed from other systems and for other services, but highlight again where in a dashboard type of situation, you might have multiple issues occurring. So you might have snow and freezing rain occurring, plus crosswinds, plus one of the runways is out. And so you can think about how you display that information to give thresholds or red, amber, green to highlight an issue, and then your operations manager may be able to delve down and find out more about what thresholds have been exceeded and is that likely to cause downstream issues or problems. And this is an example of a dashboard that's currently being used at Network Manager, which does include METARS and TAF information, but they're also using it to combine other information to highlight different airports. So what I would really love to stress is this information can be used tactically, for post-operations, tactically, for planning, both for planning the next 3 hours or for the next 24, 48 hours. And it'd be really interesting to understand what do you really want to do? How do you want to evolve your services for the modern forecasting? We've had MET information around for basically since flying first started. It became really relevant and really important. And what's the future hold for us? So this is my last slide. I think I want to really stress is that we have met information. That's in a sense what you're very used to seeing. You get a chunk of data and you do something with it. The services that are being provided on the SWIM registry are essentially the first step. This is what we think is needed. This is what we've understood from information that we've had from users. But from a service point of view, perhaps you're not interested in having a cutout over your airport. Perhaps you're interested in just having threshold information. And this is where I really want to stress again, talking to your local Met provider or those providers already providing these services and see what can be done in the future, what you would change, what you would like to see. As was stressed earlier, while we have, for example, like Wixom services out there, we're not convinced that they're actually being used yet. And is that because users aren't ready to use them and haven't put in the time to actually start extracting them, or have you tried to use them and found a problem with them? And rather than saying, oh, there's a problem with this, and it's understanding where that might be and how we can, both sides can help each other and collaborate to make these Met services in particular, but actually any swim service, useful and valuable for the wider community. As I say, we've got lots of data, but it's how we can change that story, change that information to be useful to the consumer. And I really like the picture on the right-hand side there, just showing how we can change data and use it to make the best for what we need to improve safety and efficiency within the aeronautical domain. So on that note, I think there's contact details for those of us who've spoken today, and just the link to the SWIM registry for those who wish to have a look. And on that note, I will hand over. Thank you very much.
Good morning from Madrid. It's our turn, I guess. Thank you so much for giving us the opportunity to talk about our local implementation of SWIM related services inside of a local developed tool, namely Iko Map. And for those who are lucky enough to not know me, I'm Iván Díaz. I work at an area. I'm a traffic controller, and right now, and since 4.5 years ago, I'm as well a DevOps engineer related to development of flow and airspace management tools. In this case, it's a graphical tool that we are going to explain very briefly, and then we're going to display some examples of how SWIMmet information is used and implemented into this tool. We will describe briefly what Iko Map is, and then we will show different examples of use cases that this tool enables us to do. We will then explain the benefits of using Met information inside of a local tool, namely here sourced as a SWIM information, and then the lessons that we learned in the process of implementing this information in our tool. Not just Met information following SWIM standards, but any kind of information following those standards. Some of those lessons learned have already been mentioned, but we'll go through it. So in the decision-making process, and this has been discussed a bit a couple of minutes ago, we have to deal with a lot of information that is stored in different silos, and the formats are different. The way the information is displayed or shared across the stakeholders is as well based on different standards, and this applies as well to Met information. And the best decision-making is always based on having the best information as a start. I mean, we can then sometimes make the wrong decision, but if the proper information is not there, then it is warranted that we are not going to make the best decision possible managing a situation where, for example, we have to deal with an over delivery of traffic coupled with a bad weather situation. So it is necessary for us to give our ATS, CNS, ASM, and as well our flow staff information that is integrated, that is official and from a trustable source. And it has to be updated and given it in advance to make the proper pre-tactical preparation of our operations. It has to be accessible as well, and it has to be visual because it is much easier to understand for those users when it is shown in a visual way. So information of what? Of traffic, of airspace structure, of air navigation infrastructures availability, that's NAVAIDS, and as well weather. It's a key player, and we have already had a lot of experience here in the Mediterranean Sea area during the summer. You know that it is here always sunny in Spain, not always. So what's Iker Map? It's a visualizer. I mean, the underlying infrastructure is a much more complex thing, but in terms of showing the information to the end user, it's a visualization and merging integration tool, bringing into the upstream information from different sources, some of them internal and some of them external. In this case, the MET information is sourced mainly from Imet. It has operational validity, but for traffic separation, of course. I mean, we are able to see our traffic there, but it is not intended to be used to separate the traffic. And it's scalable in terms of incorporating any other swing compliant information that is not just related to weather, but to any other things possible that are coming in the future. So it's a quite flexible tool. Of course, the MET provider here is key because we are able to display wherever they give to us. I mean, if the MET provider is not giving what we need for the upstream, then we are not even able to display it or to use it. Just to name some examples of the information sources we are mixing there, we have, of course, the aeronautical information, NOTAMs, supplements, AIS information, then as well flow information like real-time traffic load, regulated sectors, not only in Spain, but as well in surrounding airspace portions that affect our traffic, for example, Marseille and stuff, and as well for those non-regulated sectors. Are rolling our traffic load display, the sector configuration of the upstream. That means which portions of airspace are being controlled by which positions of the upstream. Then as well, airspace use for military purposes, that's UUP and UUP. And then we come to the weather information related stuff. Of course, we have there the information in the classical fashion of products, that is meter, TAF, and stuff. Some of them are displayed graphically, that is mainly GAMET, SIGMETs, and ERMETs. But then as well, we incorporate information from IMET, UMETNet, and UMETSAT with different time horizons for both observed as well as for predicted weather. We have as well incorporated the cross-border weather procedure. For those who are not familiarized with that, that is a pretty useful piece of information that is produced during the storm months for whole Europe, and it gives a very good overview of what's going to happen during the next day. We have as well radar information, reflectivity for whole Europe. Then, for example, forecasts based on numerical models offered by IMET, following two different standards as well. Nowcasting, in this case, satellite based, but radar-based nowcasting is gonna come. Of course, we're open to any other products that are going to be shared there on the same registry, and satellite images, which have been very useful in our case to deal with the volcano ashes in the La Palma Island. Of course, we have to show where the traffic is, and first the traffic position in real time is sourced and displayed from NIDA systems. So where possible swim compliant standards are used, and of course the MET provider is a key player in the process, because it is the MET provider that offers most of the information that is related to weather there. So let's go to check some use cases and examples, because I mean, this incorporation of information really brings some benefits to the upstream. And if we explain some examples, then you're going to be able to understand what this means for us and the dramatical changes it has brought into the upstream. For example, when we make the practical planning using the cross-border weather maps for the next day, we're able to see on the same HMI at the same time the traffic load that is expected on a certain sector, and as well if that sector is going to be affected by any weather-related situations on the very same display. So it is not just taking a look at the traffic load on one screen, then going to another screen and taking a look at the weather forecast. We are able to do it for the next day on the very same tool. Or for example, if we have a storm situated here in the area of Valencia, we are able to see the evolution of that storm cell real time or near real time, and then decide which holding patterns are going to be used to route the traffic to the airport. For example, if we then couple not just the traffic load and the traffic demand versus capacity plus weather, but as well if we have some regulations which are causing some deviations, we have then the possibility to see once again on the very same display the situation of those factors, then conditioning how we are going to give the service and how they interact with each other. Or for example, when military exercises are being made, you see there a red area west of Spain. If a military exercise or the use of a certain military area is coupled with a bad weather situation, we are able to see the different available corridors and the best routes available on a tactical phase to see where we have the chance like to deviate the traffic to reduce the impact to that traffic and to reduce delays. So all the time we are using the same tool as an aid to make the pre-tactical planning, but as well then on the very same day of the ops or when the ops are gonna happen, we are able to use the same tool with different layers, then not showing a prediction of the weather, but using a near real-time information of weather conditions. And then this is a very good point that we have to explain as well. Whenever you source a piece of information on a swim or with a swim compliant interface, we are able to reuse that information, then coupling it with other tools inside of the company. That is the case here. Icaro Map is not just sourcing the information, in this case, Met weather information from external sources, but as well then distributing it internally. So this applies not just to weather information, but as well to other information chunks that we get from internal and external sources. So we're just sourcing the information once and then distributing it internally. So as you see here, for example, I don't know if you see my mouse pointer. So we are able to see on the very same display, not just the traffic load and demand, but we are able as well to display if there are some regulations on that traffic volume on that portion of airspace, but at the same time, is that airspace portion affected by any weather conditions or not, on a very simple way in terms of just display a single line like under an alert. Boy, this is not just traffic that you have to keep your eyes on. There are other factors, in this case weather, conditioning how the operations are going to be performed on that sector. So the good thing about sourcing information from externals on a swim compliant fashion is that then you can redistribute that information internally on a very simple way. Here we see another good example. For example, in this Malaga airport or in the vicinity of the Malaga airport, we see how that storm cell is evolving, and we see that it is moving to the east. So we can decide that we are going to keep the north configuration, which indeed is offering a better capacity at Malaga airport, and it is much easier to work with that one. And then make the traffic with a left-hand pattern, and then maintain that north configuration, because we know the storm is not going to interfere on the west side of the airport. Or for example, here in Barcelona, we see a storm cell on top of the airport, but we see that the storm cell is going to move to the north. So we have the possibility to see very clearly that the holding patterns that we have to use for the next half hour, the ones that we have to use to route the traffic to the airport, are those being south of the airport, for example, Sabadell. So the benefits, I mean, we can clearly understand which those benefits are just from the examples, but it's a good point, like to go through some of them. There is a less cognitive load in data processing, and that brings the possibility to evaluate more options and even more complex ones, seeking for the optimal solution. So then there is improved in efficiency in terms of dealing with bad weather conditions. And this opens the gate as well for partial automation, because we can then interact with that information on our backend systems and then come with proposals to those who are going to take the decisions afterwards. And that is only possible if information is shared on a format that machines can understand. Then now the anticipation and the pre-tact phase is based on very fine-grained data whenever it is needed. Then there is consistency and transparency all across the process, because every stakeholder, both internal and external, shares the same view. I mean, they're all taking a look at the same data, not just in terms of capacity and traffic demand, but as well in terms of what is the forecast going to be for tomorrow. And then as well, that this brings us to a continuous improvement process, because then based on the stored data, we can refine our post-ops analysis. Then there is improved security as well, interfacing with external services, because as I said, we source the information just once, then distribute it internally. So we're interacting with external sources of information just at a single point. So we can like concentrate our efforts there to close the needed gates, and then they make the necessary security checks at that point. And then, of course, agility is enhanced based on these services, uh, on this service-based architecture, because it really brings us the possibility to make a continuous evolution, because it is not just a single like monster application, but we have like different canisters, there different blocks, different containers where we can patch, and where we can really make evolutions on a very more quicker way. Which factors and things to consider when transiting to a service-based architecture have we seen that are important whenever we or anybody else is sourcing and reusing weather information from externals? We have to be very aware of the interaction between the different services and their dependencies. This was already mentioned some minutes ago by Dave, I think, and it is a thing to consider that sometimes, and that is the reason why everybody needs a good architect there, like to display and to have every time quite clear what is the interaction between the different services whenever those services are going to be changed or are going to suffer an evolution. And one additional thing to consider is you have to save time and budget just for maintenance. That means that whenever an external interface is changed, you have to change your own systems as well. So don't even think that it is just going to be time and money spent on new functionalities. Even keeping what's already running costs time and money. Then as well, never underestimate the bandwidth and hardware resources, because people love data. Probably you intend to use a tool or a piece of information for a certain use case, but then even use cases you didn't envision come, and then the use of bandwidth and hardware resources spikes, of course. Then you have to be prepared to develop and deploy interfacing middleware that in itself does not bring value that is visible to the final user, but that is needed to interface with both internal and external services that up, up to now have been information silos. Of course, money and time has to be saved for that as well. Then we've seen, and that is the reason why the cross-border weather procedure is having so much success. You have to, and that is our opinion there, you have to build simple tools where explicability is a sword for the end user. People do not like that much what they don't understand. So if you offer a result that you cannot trace back to where that result or that proposal is coming from, and then people go on in denial. You have to go on, and that means that you have to go from the inside to the outside avoiding megalithic structures and like very big things that take months or even years to develop. And that is the reason why I'm really enjoying to see how the swim registry is evolving. And monitoring, of course, and that has been displayed by Dave as well. You have to be monitoring what you're doing, what you're receiving from your med provider, how often, and the quality of that information to be sure that the service level agreements are met. And this monitoring or building the necessary tools to do that once again costs time and money. It does not bring value to the end user. It is just to be sure that the services are running as they are intended to, but a thing to consider. And this is spread if at any point today or in the future anybody needs there some quick demo or any question arises, we're happy to answer it. And I hand it over to my colleagues.
Yes, excellent. Thank you, Ivan, and thank you to all that has presented and also participated. We will now go into the question session. And Ivan, if you don't mind, because a few questions has dumped in to
Yeah, I'm reading them. I'll start with the end. The information of the volcanic eruption with forecast of displacement of. Yeah, we were using the back of Toulouse, but as well we were using satellite images because at some point the back of Toulouse it gives an overview of what's going to happen on in the next hours. But if you need finer detail, satellite images were more helpful for us on certain days. The problem, of course, and it is a quite easy to understand thing, is that whenever you have clouds, additionally to the ash clouds, that is just normal clouds, you don't see anything at all. So, and we had some days of those, but we used both satellite and the information provided by the back of Toulouse. What else? The question from Joao is not for me. And then Ivan, how do you collect Imet and other metadata from swim services or from other sources? We use there a bunch of different standards. We use BMS, BFS, GeoJSON, XML, and in some cases as well, queues are used. In this case, AMQP. And then for data storage, just plain databases. And I don't think the other questions are meant for me.
No, thank you, Ivan.
My pleasure.
And we have so we have received a few also in written before the webinar. But before we jump to then, we have another one also that I will publish here. And I will, to answer this question, I will give the floor to Dennis Hart from EUROCONTROL, sitting here next to us.
Thank you, Magnus, and thank you for the question. So there are basically two elements in the question where I could give my perspective. So is it possible and will it make sense? And I also see that later on there is an indication given to a service that is available in the US through FAA. So when it comes to making it possible, of course, everything is possible. What we of course also need to understand is that for instance, the meteorological information in an ATIS broadcast is different than the meteorological information that is exchanged through a METAR. So we need to set up then an infrastructure in Europe that now allows basically the transmission or the exchange of that type of information. But that could be done through a SWIM service if need be. Then the second element, if it makes sense, that is now a question that is under consideration through a innovation hub project run together between EUROCONTROL and a number of interested stakeholders to see what really the use case could be for such a service, to share that type of information through, for instance, a single service with end users. And that is where these people are now sitting together and are trying to define what really the use case or the operational benefit is. And my understanding for the moment is that the use case or the operational benefit, especially expressed by the airline community, sits more in the part of the ATIS message on the runway use, not necessarily on the MET information or other parts in the ATIS, but really the runway in use of an airport. And if that information could be wider shared through a SWIM service, that looks to be the key focus area of that innovation hub project that is currently running. So I hope I gave a little bit of a perspective, at least from my side, and the information that I have on development related to, let's say, a single D80s or D-format information exchange. The last note maybe, in this context, it is always indeed compared with a US service. Of course, we should not forget that at the end of the day, that is a domestic US service. So they do not have the challenge of connecting all the airports or all the ATIS systems of Europe together. So again, that is why we also in that innovation hub really looked on what in the question is also articulated as what is the sense to provide such a service. And again, it looks like it is focusing on the runway in use information.
Thank you, Dennis, for the answer. And I think it should also, I think your answer is also covering the follow-up from Xiao Simios. Meanwhile, Ivan, I will publish this one. The question from Florence from Meteor France, I think was not answered the way that I think it was expected. So can you maybe go back to that, Ivan, again, and I can read it up. How do you collect Imet and other metadata from SWIM services or from other sources?
Yeah, that one was already answered. We are using their security interfaces using BMS, BFS, and GeoJSON standards. We are not using GRIP, for example, right now because it hasn't been necessary for us, but it could be the case that we're using that in the future. And then in terms of the storage, then it's stored on normal databases because it's information that can be stored there as objects or as plain text, so not a problem. But yeah, that's the way we're sourcing it. I don't know if that answers the question to Florence. And then I saw another question here as well from Florence, but I replied to that in written form. And it is in terms of, no, that was from Pavel. What is the geographical coverage of Met services provided by the registry? I dared there to answer that one. It is not just a question of what the technology offers. I mean, for example, Imet gives us the result of numerical models for an area that is a little bit bigger than Spain. If we want them to produce a forecast for all Europe, they can do that. The question is they are not designated to do so. So the question there, and that is the reason why we really welcome so well that pan-European information is shared, that it has to be given to us by the Met provider. And then the Met provider is not very keen like to take the responsibility to give a forecast or to give an information outside of that area or of that portion of airspace where they are designated to do so. And I think, and this is going to be a lengthy process, but in the future, I really envision that the global or at least the pan-European med products are going to be developed, because it really doesn't make any sense that each and every med provider is producing information and then sharing like different chunks inside of the med registry. For example, uh, and this is a very good one. For if we talk about storm predictions, do I have to source the storm predictions of Spain plus France because it conditions my traffic and how I have to deal with my traffic, plus prediction of Germany because it somehow as well affects my traffic? Doesn't make any sense. I mean, as a first step, sure, but in the future that is going to be changed. The question is right now, uh, as I understand it, each and every med provider is responsible for his or her own chunk of airspace. That is the reason why the cross-border weather procedure is helping us so much, because it gives one single forecast. Yeah, it's a simple one, but a very useful one, and we all have the same one.
Thank you, Ivan, for the answers. Very thorough answer to the questions, and to move on, I think it links very good to the question we have also received before the webinar. So I will give the floor to Pedro, who's sitting next to me, to also continue the answer of this question and linking it to the question we have here in the slides being presented now. So Pedro.
Thank you, Magnus. So yeah, we have now a set of questions which is more related to the type of content that we have in the registry and who is providing this content in the registry. So basically, the first question we have here is mostly about who is actually providing the services. Who is it about the only certified service providers, or is it a definition which is wider than this? So I think the short question for this is basically no. It's not only about certified providers. The intention of the registry, and you can find a bit more information in the terms of reference that are also published in the registry. The idea is that we will have providers of services. Some of those are actually for services that are certified, like with the regulation 373. But however, you may have also other added value services to a European ATM that actually are worth to be discoverable through this repository. So basic question, basically the answer is it's wider than regulated providers. And that takes us also a bit to the next question is how do we, once we have a bit of a criteria on the content that goes in the registry, how are we actually validating that that content is basically matching the criteria? So in terms of criteria, I think we see that it's about services of value to European ATM. We see also that it's about SWIM, so it's about alignment with the SWIM specifications. So we have a criteria defined. How do we make sure that actually it's only those services that fit that criteria that are being published in the end? So there the approach has been automate as much as possible. And that's actually the result of a discussion we have within the registry CCB, so the Change Control Board. The registry has a group of people that represents the community, a group that is actually open to any of basically of the European ATM stakeholders. And basically within the group, apart from defining a bit the criteria in terms of the what is being published, we also try to define the process that actually then the registry provider has to ensure is followed. So in terms of process, the process we went for is automation as much as possible. We didn't want to create a group that will monitor and be always in the loop for every service that is being published that will be enforcing that criteria. So we went to capturing as much as possible in the description of the services the attributes that have to be validated. And that's why you've seen it all already in the presentations before. There is an extensive effort to make sure that the services are described, and those descriptions serve to validate the publication in the registry. So we put in place validation as much as possible. Now, if we see that we need more than this, actually the registry CCB is the place for discussion. And actually, I will take this, I will turn this into an invitation for all of you to contribute to that registry CCB, where basically we would like to continue next year with active sessions within this group. We are actually lacking a chairman for the group, so invitation to all of you that would like to have an active role in defining how this registry operates. Basically, the offer is there for you, and soon you will hear more in terms of the next sessions of the registry CCP. Yeah, thank you. Okay, I think that's covered now.
I think we have covered these questions by Pedro already. So if we move on now to questions related to IWIXM, and luckily we have Rosalind with us today, who can help us answer these questions.
I'll try my best. Thank you, Magnus. So the question is, if I can read that properly, what are the limitations on different parties converting TAC to IWIXM? Well, the regulation, both at ICAO level and at European level, puts the onus on the producer of the meta information, whether that's a METAR or a TAF or a SIGMET. They have to produce it in IWIXM format, and that is mandated by regulation, and the oversight will be done by that state's competent authority. At the moment, because we're in the very early days of publishing in IWIXM, not every state has the capability to do that themselves at the moment. Excuse me. So there is an allowance at the moment, and for many states, that translation is being done by the regional OPMET centre. So that is a fully audited and transparent process that is documented. But if I wanted to set up a TAC translation in my garage, then of course that is not allowed, because that is not any official process. So in other words, the services, the MET services that are defined in the regulation have to be produced in IWIXM by the designated entity that is allowed to do that within the state. They may well set up a private arrangement for some third party to do that on their behalf, but again, that is a fully transparent process. So there should never be a case where there is spurious random versions of IWIXM out there for regulated products.
So there is, I think there's 3 questions concerning IWIXM. So this is the second one, and then you have one more, and then we will. Sorry about that. We jumped also some of the other questions. So I will jump back and forth a little bit. I hope you don't get too confused. But Rosalind again.
Well, I think the question that's on the screen at the moment kind of addresses the same thing as well. This is a scenario whereby you have different versions of IWIXM for the same thing. What I've just explained is that we should never have that that occurrence. Of course, that's not to say that you couldn't have a swim service which uses that IWIXM as an input. It does something with that information or merges it with traffic information, for example, and comes out with a new service. I think that's to be encouraged. But in that case, it's not amending, it's not changing that original core meta information that came from the designated provider. Okay, so this question, how are the recommends and demands on service providers being able to produce IWIXM natively directly in the tool? I'm not quite sure I understand that.
I think it was the one that talked about in the where we promote the production of the native.
Yeah. Okay. So, as we said at the moment, a lot of states are simply just translating the old version of TAFs and METARs and SIGMETs, etc., into iWixom. What we're talking about, I think, in this question is that if we move away from that and we are producing it directly from the observation or from the forecast, from perhaps from the numerical weather output, that is going to be the end state of this. This process we have at the moment of translation is seen very much as a transition. It's a first step, if you like, in order to get iWixom out there and being used operationally. But the end state is this migration to producing it natively. I hope that answers the question.
Thank you, Rosalind, for the answers. And please, if you have further clarification needed, then just add it in the chat. We look at the chat all the time. And we will jump back to question 3, which we did not cover before. And back to Pedro for that one.
Yeah. So basically, now we have 3 questions that are a bit related to service design or service harmonization. The first question is a bit on the how do we choose to design our services? Is by technology? How do we group? In the end, basically, it's about the provision of information, and you can decide to have services that actually define their scope, for instance, based on the technology they use of their interfaces, based on the information they provide. There is not like one rule that can be applied in every case. I think in terms of technology, it is indeed it's a good way of grouping your services. We've seen it already in some of the presentations this morning and some of the services in the registry, when different technologies, different services have been used, even if that was for providing the same information. That's certainly an acceptable way of doing things. If we go, for instance, in question 4, question 4 is mostly is pretty much the same thing. It's about how do we define the scope of a service. It's by information, by how granular we go, and that is where I see also a recurrent question, which is, are we going to have for every service provider 4 services in the registry? I think we see already that the answer to this is no. In fact, we see that the CP1 defines the intentions of information, met information to be provided to enable certain scenarios or certain areas. So basically, that you do that with a single service or with 4 services or multiple services for each of these information exchange purposes. I think this is up to you. It is, however, true that if with all the providers we have the 27 and we all follow actually a different approach, it is certainly potentially is not the best scenario. So I think we could look at how do we harmonize the provision of those services. It is clear that we have already a few services in the registry that potentially will guide other providers in choosing a particular way of scoping those services. But I think it might be seen that we need to have potentially some further discussions with the Met community to see what is possible that can be done for harmonize this service even further. The last question is on mostly, I think, a conceptual question is a access point in the service. So I think a service, and that's something you can see in the EUROCONTROL service description specification. It describes the elements that are part of the service. The service will have a certain functionality. That functionality will be available through an endpoint and address. So basically, the access point is not the service itself, is actually a part of the service. The service is a set of elements that enable that you exchange data with another stakeholder. So I think it's mostly, I think, conceptual. And for more information, I think I'll invite you to go to this spec. It will give you an overview of all the elements of the service. Yeah, thank you.
Thank you, Pedro. And I would also like to highlight the SESAR deployment program, which was also part of the Florence question here. That it's important. Also there, we have highlighted that there needs to be a collaboration between the provider and the consumer for definition of actually what are the requirements, what do we need in this. Let's go back to Q&A mode if we can. We have some more questions which has dumped in. I think we have one here again for Pedro. He's the lucky one today. So we have a lot of internal discussions trying to understand some SWIM implementation issues. For example, should med provider communicate with HCS provider via SWIM compatible protocol and using SWIM format messages, even if med provider and HCS provider are part of the one ANSP? I think I'll give the floor to Pedro again to answer this one.
Yeah, I think there are two possible ways of seeing this. On the one hand, indeed, if you have already a collaboration or an exchange with another organization, I think you can keep potentially doing the things you were doing before. But however, the intention of services is actually that you provide information in a way that is not exclusive to a single consumer. So if we take the example that we've seen before, if we are having already someone consuming information for a particular case, like I think that the explanation of an before, I think it was a good one. Is that information coming through a SWIM service, or is it coming through another internal channel that will enable the same, basically the same type of consumption? I think from the provider perspective, what is expected is the information is provided as a service described in the registry. That will enable not only an air, in that case, consuming the information, but it will open the consumption of that information to the wider community and respecting a standardized way of disseminating the information. So I think in the end, yes, I think we will expect that actually the even be something that is happening today internally within the, we'll say the same organization when it is about med provision, and when we look at the CP1 in terms of how the med provision is expected to be provided, I think the answer will be via SWIM services.
Thank you, Pedro. So we are almost in the end. We have a few more questions that dumped in here that I would like to see if we can handle. The first one is, what will happen with Rocs after full implementation of SWIM? I'm looking to my left because there's an abbreviation I actually don't know in aviation. There are many, but I'm looking at Dennis or Rosalind. I think we'll pass the ball to Dennis this time.
So thank you, Magnus. So ROC stands for Regional Opmet Center. So that is a function in the ICAO framework to distribute and to collect and to assemble meteorological information in the current ways of exchanging it. So the future of ROCs are integral part of the discussions that are taking place at the level of ICAO. So the reference that already was given by Rosalind on the ICAO MET SWIM plan, or the evolution to SWIM of MET, also talks about, I think, 2 or 3 scenarios where the role and the responsibilities of ROCs and the changing roles of ROCs is explained. But again, that is a subject of further discussion also at the global level in the ICAO MET panel.
Yeah, thank you, Dennis. I hope that answered the question. I think we have 3 minutes left. We have one more here. How do you organize the services when 500 services from each of the 50 providers are available? From Lars Erik Julstad. I think Pedro is ready to answer this one also.
Yes, so actually the registry already provides you a taxonomy where that we are asking to be used that will help basically the consumers to identify by CP1, for instance, family, by the information type, by types of protocols. So we would like to make sure that actually that indeed as part of the publication, it is a structured publication, and we can tell services apart based on this taxonomy.
Excellent. I see that time is up, and I don't see any more questions dumping in last minute. We have answered some questions in the chat. Also, if there's any elaboration needed, then please don't hesitate to reach out to us offline. Also, I think we need to wrap up this workshop webinar at this point. So I would like to thank all of you for joining, for the one presenting and preparing the presentations. I think it's very important that we keep the dialogue on this running, and especially also now that focus has been a long time of the service provision, we really need to start looking at also the service consumption, as also stated by Lauren from UMedNet. The data will be out there. It is out there in many cases, and we just need somebody to actually use it. And I think it was excellent to see Imid already making a lot of progress on this behalf, something that we can learn from in the rest of Europe. So thank you all for joining. Have a nice day. And if you have any more questions, please reach out to us. Bye-bye.